As you look at the next 5 years, the next 10 years of, maintenance, reliability, and manufacturing, like what are some trends that you're most excited about?
I hate talking about this because I think there's a lot of false promises with it, but it really is artificial intelligence and AI, or building models around maintenance and reliability of your assets. The biggest trend I think that we're going to see is, or the shift is, there's a lot of big companies today who are trying to build these models on their own, like makers of things. They're not the ones that make the pumps and the motors and the machines, but maybe they're like Ford, right? And they have, really big reliability issues on some of their equipment. So they're trying to build predictive models on failure. And I think one of the biggest shifts that we're going to see is the actual makers of the motors, or the things that you're in the machines that you're trying to predict failure on, are going to start building those models and connecting to those machines, because they're the experts in those, right? Like somebody like Ford is definitely going to have internal people that are experts in whatever kind of machine or robot that you have, but a mid-sized manufacturer is not. And they could really benefit from that technology and all that aggregated data across all of those different robots, machines, motors out there in the field across the world.
I totally agree with it because, I think what's happening is that, pump A from company and brand A, even it's the same like rotations per minute, same horsepower as, pump B from a different manufacturer, from a different company, operate in slightly different ways. And we can't necessarily say everything that happens to, this pump is going to be directly relatable to pump B. But if you are actually the manufacturer, I'm sure you could set a standard for what's in range, what's out of range. And the manufacturer is actually going to be in a better position to tell, us as the operators, is this in line or out of line?
But when you get into like a complex piece of manufacturing equipment, like a CNC, for example, where you can do anything, right? And so there's so many different failure modes on that thing, depending on what you're doing. So like the way it'll fail if you're cutting plastic or wood is different than titanium. And the tools make a difference too. So then having the ability to combine all that data together and contextualize it, and then know what the failure modes and what you're predicting based on what the thing is doing and what it's supposed to be doing, I think is really important too. Because a lot of what we focus on today is just, do we have an anomaly, for example, right? Is a vibration pattern anomalous? Is the temperature too high? Is the flow rate wrong? Current draw wrong? Things like that.